Hi guys, I'm here now to present a cycloid construction tutorial. So how to explain cycloid construction? This is a circle here, and all a cycloid construction is tracking a point on a circle as it travels along a straight line. So this straight line we would then discover, well, on this straight line we will find out what is the circumference first. And why the circumference is important is the circumference is the unfoldment of the circle as along a line, and that would then determine how far this circle needs to roll until it completes one revolution. So, but in theory, but practical, circumference, the circle would move like this, and this is the point that we are focusing on, and we just watch this point move. So when it gets above us, like that point, you know that it's at halfway up here, and then it comes all the way back down, and the point comes down again directly facing south. We know that we've made one complete revolution. Anyway, we will plot that, and we will see it better as we plot it down here. The circle that we are going to be using is a circle of 35mm radius, which that means we'll have a diameter of 70 millimeters. So let's just plot the circle, 35mm. Find this point here, and we're going to start with our circle right here. I think everyone can see that circle there. Right. And the first thing we're going to do with this circle now is we're going to divide it. Divide it into 12 equal pieces, using a 60-36 screw. So now that this is all divided, the next step is to project these division lines here on the circle to the right, across. But before we do that, let's number the circles. So directly above at the starting point is 0, or some people call it 12. And we go around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to 0 or 12. So now let's project these lines to the right. And we are pulling points from where the division lines touch the circle. So 11 and 1 would be the same horizontal line. 10 and 2 would be the same. 9 and 3 has already been projected across. 8 and 4 would be the same, and 7 and 5. And then there's 6. And then the top line 0. So these are our lines that we have going to the right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 lines going across. Now what we need to do is we need to find the circumference of this circle. So we have a circle that is diameter 35, d equals 35, and pi equals 3.14. So that's pi. Or some people call it 22 over 7. So when we multiply 3.14 multiplied by 35, we get a figure like that would be 219.8. So what we're going to do is just round that off to 220. Okay, now what do we do with that information? This first point is where we're going to start. So let's call here A, and then we're going to measure off 220 along these horizontal lines. So that's 220. Come in somewhere right here. Right? And then we will call this last point B. This is the finishing line. We call that B. So what do we do now? We need to divide A and B into 12 divisions, similarly to how the circle has been divided into 12 divisions. So for that, I'm going to pick a point at 0, and just project this line here. You see, I'm looking to just put this line that I'm dancing on anywhere around here. This is an arbitrary line at any angle. This line is just for constructing, making our construction points. So let's call this line a construction line. Construction line. What do we do on this construction line? We mark off 12 divisions, 12 equal divisions. So for that, I'm going to use my set square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divisions. Just label them as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do we do with these 12 divisions? Well, this whole process started at A. We made the line. So now what we do is we connect point 12 to B. We get a nice little line here that we are going to use to help us divide the actual real line into 12 parts. So that's the first line. What we need to do is we need to set up 2 set squares and track. So we're going to track in the properties of this line going through each point. That's 12, that's 11. Let me just reset up my track properly. Go ahead and set up the track properly as you go so that these divisions are accurate. 10. Luckily for the new students now, they're taking up the skill of technical drawing. You don't have to do this division process actually anymore by hand. You're using AutoCAD, and with a couple clicks, you could have a line divided. So it saves a lot of time. But I guess there's some fulfillment in being able to produce this. You know, the manual. Anyway, let's get back to what we're doing here. So now, I have divided my construction line to 12. I've transferred my divisions from my construction line down onto my rail line A, B, divided into 12 segments. So what do I do? Now I need to create my grid. Project these lines downward. So I'm going to find these points. 1. Let me just use a different pencil so we can get some softer lines. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then back to 12. Okay. So seeing the circle's axis is here, I need to highlight these points. So I'm going to highlight the points that the circle needs to pass through in order to make the final stage complete. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to 12. These points here that I've just highlighted, this is where my compass will go. I'll start my compass there. So now let's start this process. Circle here that we started, 35 millimeter radius. So point 1 is going to here. It's going to be right here. This is our first point. So this is where we're starting. Now as we go over to point 1, we need to move up this line. So for each point that we go down this number line, we move up the horizontal line. So 1 comes in here. 2, move up the horizontal line again, and we use the line 8 and 4. 3, as we go down, we use the line 9 and 3. 4, we use the line 10 and 2. 5, the line 11 and 1. 6, we use the 0 line. And now when we get to 6, we recognize that we are halfway. We are 6 out of 12. So 7, we start to descend. We use 11 and 1. 8, we use the 10 and the 2. 9, we use the 9 and the 3 line. 10, we use the 8 and the 4 line. 11, we use this line, 7 and 5. And then 12, we come back down to our 0 line. So those are our points, and now let's put in our curve. Our curve will look something like this. Okay, so that's our curve, and this construction is called a cycloid construction. Thanks for joining me today, guys. Hope you learned something, and stay tuned for more tutorials. So just recap before we finish. This is the actual rotation of a circle going the distance of its circumference, creating this arc, and this arc is called a cycloid. That's it. That's a wrap.